Alright, we're back for the next piece of our Chapter 15 review for CNT140. We're talking about the two different test types. Make sure you do know the permanent link in the channel. Make sure you know what's included. We're going to do the permanent link when we certify our lab, but make sure you know what's included in each test. And as we move on, they say there's two different performance levels that we should consider. One is the actual performance category of the cable system, matched to the ISO standards, and the accuracy of your field tester. All right. This got a little confusing in the book. So what I did was I took what they had mentioned in the book and kind of reformatted it into one chart for you. Here is everything in one shot and one step, showing you we're used to the category, 568C categories, 5, 5E, 6, 6E, 7, 7E, etc. down the line. We're used to those. ISO classifies them slightly differently, so here's the matchup. ISO says that's Class D, Category 6 is ISO Class E, Category 6E is ISO Class EA, augmented if you will. Category 7 is Class F, and Category 7E is Class FA. So there's the matchup between the what we're used to, the 568C standard categories, and the ISO classes. Now, what gets added on top is the field tester accuracy for this. So what it amounts to is, if I want to certify 5E cabling, I need an ISO Class D meter or a field tester accuracy level of 2E. So here's the matchings, and what it boils down to is, if I'm trying to certify Category 6 cabling, I'm looking for a meter that is level 3 accuracy or better. That's what it boils down to. So let me now take you over to the manufacturer site, and here is one of the Landtech meters, cable certifier. And if I look down through, after I just showed you that chart, this makes a heck of a lot more sense. Right under the features it says, best performance options, models ranging from 350 to 1000 for Category 6 ISO E through Category 7 ISO FA. And if I go back to my chart and kind of look at it again, there they are. Okay, so they actually show you, they're saying here it's rated to blah ISO class or blah level of meter. And if I do the same thing on the Fluke site, here's the Fluke one, almost right off the bat, unmatched speeds for Category 6A, Class FA, and all other current standards, etc., etc. And they even, I think in here, even shows you the level. Yeah, actually, level 5, the most stringent accuracy requirement. So there's kind of the matchup. The takeaway for you, let me go back here again. The takeaway for you is, make sure the meter you're using is able to actually certify the category of cabling that you're certifying. That's the takeaway. And if need be, pull up a chart like this that I made for you and make sure blah is matching blah, blah is matching blah, so that you know it's actually certifying to the level that you need it to. That's your takeaway. The book kind of spent 2 or 3 pages on this to know, and it actually got a little confusing, so I tried to sort it out. And again, the manufacturer page or the specifications page for that meter will tell you. It is there. Cost for testing, a lot of times this isn't, when the cable installer installs your cabling, what's normally included in like install and labor is the continuity and wire map testing, just making sure it works. There is usually extra cost for certifying with your certification meter, and sometimes it's 5 or 10 or 15% of each cable drop cost. We will factor this into our plan, into our project. We will factor this cost in just so you recognize how you would do that. But typically certification does cost more money. And as we said, we need the cable certifier to do that, and it's producing a result where you get a printout saying that everything is passing. The meter itself is relatively easy to use. When I use the auto test feature, it actually goes through the battery of tests that are required for it to pass certification. And if it passes, it'll come up and say pass. You go through a couple buttons and say save, saves the test results, and you move on to the next cable run. And then later on you can take it back to your desk and download those results using USB cable. And again, we will do that in the lab so you know how that works. What's usually required, if you go back to TSP 67, they define again the performance and the tester performance. Then they also say at least 4 tests must be done for it to be certified. Wire map, length, attenuation, near, and crosstalk. All right, let's go through these real quick. Wire map, it's making sure that everything, well, horizontal cabling should all be straight through. There should be no crosses, reverses, opens, anything like that. So it's going to verify that our cabling is wired straight through as it should be. And I should be seeing the top wire map, if you will. Anything else would not pass. And things like cross pairs where, orange and green are swapping places would not pass. A reverse pair where I accidentally wired the green pair backwards would not pass. A split pair where I accidentally flip-flopped, the white orange and the white green wire would not pass. So it's actually checking for straight through wiring, and only this one, I know it's super boring, but only this one here would pass the wire map test. When we do our troubleshooting chapter, I think it's 17, chapter 17, we'll go into these in more detail and kind of sort these out for you. It also needs to pass length test. Again, if you set your meter up to do permanent link, the installed cabling should be 90 meters or less because it's just testing the horizontal cable run. If I do a channel test, it should be 100 meters or less because that's including the patch cables. Attenuation. In the standard, it calls for allowable limits. So if I'm doing category 6 cabling, as long as it's below those allowable limits, you're okay. Same thing with the earn crosstalk. If I'm doing category 6, in the standard, it has allowable limits. As long as it's that level or less, we're good to go. So it's going to run through these battery tests. So when you hook up the meter and hit the auto test button, it's going to go through. You're going to hear it clicking, click, 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 click. It's going through a battery of tests to try all these things. If it passes, it's obviously recording that data, and then it'll also say that test has passed. And all you have to do is save that to take it back to the office and print it out. And that's here. Again, when you're done, it's going to produce a report, and you're going to download and print out the test results, and one set should go to the customer and one set you should keep on file just for future reference. That way the customer comes back a year or two later and says, this doesn't work, it's never worked. You can say, well, when we installed it and tested it after install, we had proof that all these work. We will helpfully come fix your problem for you, but they did all work when we left. It's kind of the whole necessary documentation, if you will. Last part, they talk a little bit about testing equipment. So this is kind of a refresher of some things, but a reminder of some things we just mentioned. Continuity testers. This is typically used right after the install. Well, we've been doing this all along, all semester. Right after we installed our cabling, we hooked the continuity meter up and made sure we had a complete path. And real quickly again, this end of my meter actually has a battery in. This sends a signal down the wire to the other end. The other end loops it back and sends it back to here. And if we get a complete path on, the orange pair, a little light in here says, yep, we got a complete path. And then it does it for the green and the blue and the brown. So as I go through, if I have 4 complete paths, I should see 4 complete lights there. And if anything got flip-flopped, it usually indicates with a cross pair, reverse pair kind of thing. But the continuity tester is really only just checking for a complete path. That's it. Nothing about attenuation, near, and crosstalk. It's not capable of doing that. But that's your first test that is actually quite valuable, that can actually troubleshoot, that can find lots of your wiring problems for you right off the bat. It's completely very valuable in the process. The next tester we use, and actually we're going to be using this during the troubleshooting lab, is our wire mapping meter. You actually used one version of this earlier this semester, the squarish yellow fluke that gave you a wire map. We're going to use 2 of these when we do the troubleshooting part of our semester, part of our lab in like 2 weeks here. This is actually going to send a signal down one wire pair. As it gets to the other end of the run, the return unit on the other end sends it back the other pair, and then it's going to say, okay, if I send it down white-orange, it should be coming back orange. If it does, it indicates it and shows a wire map on here. And any kind of wiring problems, it starts showing. Like this screen here is showing the orange and brown pairs have been flip-flopped for some reason. So the wire map is showing a crossed pair. In this case, the orange and the browns. This is very valuable for helping with troubleshooting improperly wired terminations. Again, if you wired one end of your cable run 568A and the other one B by accident, it's going to show cross pairs, and this will show you very quickly what your problem is. Your wire mapping tool is very valuable for troubleshooting these wire termination issues, I like to call it. Cross pairs, reverse pairs, opens, those kinds of things. Your cable tracers, or also called toners and probes, or also called foxes and hounds, allow you to find a cable. Now, these really came from phone days, where I wanted to find a wire pair off of a whole block because I needed to pull it out, move it over, and punch it into a new spot. But this can also be used for data. Here is a toner probe. There is actually an RJ45 and RJ11 connector here, so this can plug into a phone jack or a data jack, and this allows me to send a signal down the wire. This part here sends a little electronic warble into the wire, and this probe end here, as I lay it near the cable, picks up that through induction, and there's a speaker usually in the handle that will play that tone. So it allows me to plug this into an outlet jack, go into the closet with this end and find that cable. Maybe something got mislabeled, maybe something got cut. I can find that cable, find it, and locate it for troubleshooting, or pull it out, re-terminate it, put it in the proper place, whatever. This allows me to trace that cable tracer. Extremely valuable tool when you need it, especially when you're trying to find a cable out of a bundle. Certifiers, which we've been spending a lot of time on this chapter, these are the ones that are going to test your performance levels. Near and crosstalk, attenuation, impedance, length, all that jazz. They're the only ones that can do it. Save it, download it, print it out for performance. Alright, so as we hit the end of the chapter here, they're reminding us that, the certification is an important part of this. We need to be using properly labeled components, outlet jacks, cable, patch cables, all that jazz. And then we also need to use proper installation techniques, which we've been doing all semester. And then last but not least, hooking up a meter to verify that all of this is performing to Category 5E level, or Category 6 level, or Category 6E level. And all of that whole package there together is going to ensure that the cabling will be able to support gigabit or 10 gigabit out to the desktop. Extremely important.